Hello everyone. In this video, we are going to start a new chapter, that is integral calculus. Integral calculus or integration is the inverse process of differentiation. Now, if you remember, the process of finding derivative of a function is known as differentiation. In the case of differentiation, we are given a function and we need to find a derived function. Say we are given a total cost function and we need to find a marginal cost function, or we are given a total revenue function and we have to find marginal revenue function, and so on. So in differential calculus, we are given a function and we need to find a derived function. However, in the case of integration, it is the opposite or the reverse. In integration, we are given a derived function and we have to find the original or the primitive function. So such a process of finding the original or the primitive function from the derived function is known as integration or anti-differentiation. Now, if we are given a function y equals x square, on finding the derivative, that is dy by dx, we will get the derived function 2x. So that is differentiation. In integration, we will be given the derived function, that is 2x, and we need to find the integration of it in order to get the original function x square. So given the function x square, when we find the differentiation, we will get 2x. In the case of integration, we are given a derived function, that is 2x, and we have to integrate to get the original function, that is x square. In order to find the original function or the primitive function from the derived function, we write the integral sign or elongated s, the derived function 2x or the integrand, and dx. X here stands for the variable with respect to which the function is to be integrated. Now, on integrating the derived function to x, we will get x square. In the upcoming videos, we will discuss in detail the different rules of finding integration, all the basic rules. Now, on integrating this to x, we are getting the original function as x square. However, given a derived function, we will not get exactly the original function. Why? The reason being that the original function might be y equals x square plus 4, or y equals x square minus 15, or y equals x square plus 0.5. The derivative of all the three functions is 2x. So if we find the original function from the derived function, that is 2x, in case of all the three functions, we will get x square. And we might not know the original function, since in all the three cases we have a constant term which are different. So in order to take care of the constant term which we may lose in the process of finding the integration, we add c. This c stands for constant of integration. So we can observe that in all the three functions here, that is y equals x square plus 4, y equals x square minus 5, and y equals x square plus 0.5. On finding the derivative, we see that we are getting the derived function as 2x. So given a derived function 2x, on integrating the derived function, we get x square. And we might not have an idea of how the original function may look like. The original function may have a constant term associated with it, say x square plus 4, or x square minus 15, x square plus 0.5, whatever constant term it is. So in order to take care of that, we add c, that is constant of integration, in order to take care of the missing constant term which is associated with the original function, or which may be associated with the original function. To integrate any function, we write the integral sign or elongated s. The function to be integrated, it is also called integrand. Here x is the variable with respect to which the function is to be integrated. So if we are to find the primitive or original function from the derived function to x, we write the integral sign or elongated s, the function to be integrated or integrand, and the x. Here x stands for the variable with respect to which the function is to be integrated. On integrating the derived function to x, we will get x square. Now why we are writing c here, which is the constant of integration? Because the original function may have some constant term associated with it, which we may fail to take into consideration if we don't write the constant of integration. As we have seen earlier, from the original function, say x square plus 4, on finding the derivative we get 2x. However, on finding the integration of 2x, we are not getting x square plus 4 back. We are missing 4. So in order to take care of the constant term 4, we are writing c. There are two types of integral. The first one is indefinite integral and the second one is definite integral. So far what we have been discussing is related to indefinite integral. We will discuss in detail the difference between indefinite integral and definite integral in the upcoming videos. So please try to remember that integration is the reverse process of differentiation. What we are doing in differentiation? In differentiation, we are given a function and we need to find the derived function. Say we are given a total cost function and we have to find the marginal cost function. And in the case of integration, we will be given a derived function, say marginal cost function, and we have to find the original function, that is the total cost function. Please remember that while finding the indefinite integral, we also write the constant of integration in order to take care of the original function, because the original function may have some constant term attached to it. And while finding the integration from a derived function, we may not be able to exactly get the original function, or we may fail to get the original function with the exact constant term. So in order to take care of that, we add the constant of integration. Thank you everyone.